Hi, in this video we're going to talk about normal distribution again and something called a continuity correction that you'll see on some sample questions. So let's get into an example. I'll show you what I mean by that. So first of all, we're going to do an example first without a continuity correction, and then I'll do the same example with a continuity correction. So here we got a student that takes a multiple choice test with 100 questions. The probability that the student answers a given question correctly is 0.5, independent of all other questions. Use the normal distribution to approximate the probability that the student answers at least 53 questions correctly. Okay, so let's let capital N equal capital N denote the random variable representing the number of questions that's answered correctly. Now capital N is counting. It's a counting distribution, and actually it's if we think about it, if we say that answering a question correctly is a success, then we're looking at how many successes. Capital N is counting the number of successes in 100 independent trials. Capital N is nothing more than the binomial distribution, with M being 100 and P, the probability of success, being 0.5. And we seek the value. We'd like to know the value of that probability, or the probability that that cap N, the number of correctly answered questions, is greater than or equal to 53. But the problem says to use the normal distribution to approximate that probability. So how we go about doing that is we have this binomial distribution. We can calculate the expected value of the calculate the expected value of this binomial distribution and the variance of the binomial distribution. I have those values shown, and then what we'll do is we'll say that the cap N random variable will approximate cap N using a normal distribution with the exact same mean and the exact same variance. And so we'll say cap N is approximated by cap X, where cap X is a normal distribution with a mean of 50 and a variance of 25. Then the probability that cap N is greater than or equal to 53 would be approximated by the probability that cap X is greater than or equal to 53. At this point, cap X is a normal distribution. It's not a standard normal distribution, but it's a normal distribution. So we go through the process of standardizing it, and then we see the value we actually seek then is just the probability that the standard normal distribution is greater than or equal to 0.6. Now again, to use the values in the table, I need probabilities that cap Z is less than or equal to a positive value, but I can use complementary events to say that the probability that cap Z is greater than or equal to 0.6 is 1 minus the probability that cap Z is less than or equal to 0.6. And then I just find 0.6 in my table, pluck out the number that's corresponding to a 0.6, because that's the probability that the random variable cap Z is less than or equal to 0.6. So I'm plucking out a 0.7257 there, and I get a value of 1 minus that 0.7257, which is a 0.2743. All right, so I didn't actually use anything having to do with the continuity correction here. I just wanted to go through this process first without it to show you how we're going to use the normal distribution to approximate a binomial distribution. We do it this way. Okay, so now let's go back to our problem. This is the problem as it's stated. And now look at the last sentence there where it says use the normal distribution to approximate. I'm going to change it up. Now I'm going to say use the normal distribution with the continuity correction to approximate the probability, the same probability that we have. So I'm going to start it off the same way. I'm going to recognize that cap N, the way I have it defined, cap N being the random variable representing the number of questions answered correctly, that cap N is following a binomial distribution with an M equal to 100 and a P equal 0.5, and we're seeking the probability that cap N is greater than or equal to 53. I'm going to go through the exact same process. I'm going to say cap N is approximated. I'm going to approximate cap N, the binomial distribution, with a normal distribution, where the normal distribution has the same mean and the same variance as the binomial distribution. So far, everything is exactly the same. But at this point, I recognize that cap N is a discrete distribution and cap X is a continuous distribution. So the question that's posed is, well, what X values, when we round them to the nearest integer, would give cap N values greater than or equal to 53? What X values, when rounded to the nearest integer, give give values greater than or equal to 53. And of course, the answer to that is you would need cap x values greater than or equal to 52.5. If you had a 52.6, that would round to a 53. If you had a 52.4, it would round to the nearest integer to a 52, not a 53. So here, cap x would be greater than or equal to 52.5. So the continuity correction says when you're approximating then the probability that cap n is greater than or equal to 53, take into account that cap x is a continuous distribution that you're approximating this discrete distribution by, and so take that into consideration by again asking that question and using the results from that question. So the probability that cap n is greater than or equal to 53 would be the probability cap x is greater than or equal to 52. Cap x is, from here on out, it's exactly as we did before. Cap x is a non-standard normal distribution, so we standardize it. We see we're seeking the value that cap x is greater than 0.5, which is 1 minus the probability we're seeking the probability that the standard normal distribution is greater than or equal to 0.5, which is 1 minus the probability the standard normal distribution is less than or equal to 0.5. Pluck out the value from 0.5 from the table, which is 0.6915, and I see that my answer then for this, if I'm taking into account the continuity correction, my answer is now a 0.3085. Before, the answer was, I think it was like a 0.27 number, 27, around 27%. Now it gets bumped up to 30% when we take into account the continuity correction. Finally, let me make another comment here, and let's go back to this part of the calculation, which is where we how we would set this thing up using a continuity correction. Notice that if you look at the last sentence in the last line, it says, I'm looking that the probability the students answer at least 53 questions correctly. If I change that from at least 53 to more than 53 questions correctly, then we'll see some changes here, because more than 53 means that cap n is greater than 53, not greater than or equal to 53. And remember, cap n is a discrete random variable. It's either a 53 or a 54 or a 55 and so forth. And so the question then becomes, what x values, when rounded to the nearest integer, give values not greater than or equal to 53, but greater than 53? And you could think of that as greater than or equal to 54 if you like. And then the answer then is that cap x would need to have values greater than or equal to 53.5. And my answer then would be that the probability that I would seek, if the question was probability that students answer more than 53, that's cap n is greater than 53, that probability would be approximated by the probability that cap x is greater than or equal to 53.5. So pay attention to the details of the problem on these continuity correction questions, because I can almost assure you that if you miss that continuity correction by one, that's probably going to be an answer choice. So again, pay special attention to those to the details of the question. Okay, so that does it for that's what the continuity correction is, and I'll see you in the next video.